So in our last section, we talked about a probability distribution. And in this section, it's actually two sections sort of combined. We're going to talk about the binomial distribution. So what it is and how we can find the mean and the standard deviation. So a binomial distribution is a specific type of probability distribution. In order to determine if a distribution is a binomial experiment, the four statements must be true. So we just want to go through always these four things in our head to determine, is it a binomial experiment? Sometimes it's also called a Bernoulli trial. So the first thing is there's a fixed number of trials, n, which means that the experiment is repeated a specific number of times. So it could be maybe 10, maybe 100. Doesn't really matter the number, just that there is a specific number of times. The second is that the n trials are independent, which means that what happens on one trial does not influence the outcome of other trials. So if they're dependent, it could not be a binomial distribution. Third thing is that there are only two outcomes, which are called a success and a failure. So if we think, right, it either happened or it didn't. And four is that the probability of a success doesn't change from trial to trial, where P is equal to the probability of success and Q is the probability of failure. So if you know one, you can find the other one very easily because they're complements of each other. So the outcomes of a binomial experiment have a binomial probability distribution. Here the random variable x represents the number of successes obtained in the n independent trials. So we write, so a lot of times they'll write the distribution with just, in this case, right, the number of successes and then the probability. But it just says x is distributed as, and it's a capital B for a binomial, and then it tells us some information about it. And just to note that a success does not necessarily imply a good result. It just means a success simply indicates that the event of interest occurred. For example, if we are considering the probability of being diagnosed with cancer, then being diagnosed with cancer is our success. So just keep that in mind. We do have a binomial formula for the probability of our successes in n trials, and it may be a little bit hard to read. Let me zoom in just a little bit here for the minute. So it just says the probability of x is equal to some r is, so it's a combination, right? We looked at combinations a little bit earlier in the class. So n combination r times the probability, or sorry, times p raised to the r power, and then q raised to the n minus r. And we'll go through, and we can actually do this in the calculator fairly easy, but this is sort of the more formal definition of our formula. Our mean and variance and standard deviation for a variable that has a binomial distribution r. So I have mu, right? So the mean is equal to n times p. Sigma squared, or the variance, is n times p times q, and the standard deviation is the square root of n times p times q. And just remember, right, where p is the probability of success and q is equal to 1 minus the probability of success. So q is basically the failure. All right, so let's take a look at our first example. Let me zoom in or zoom out just a little bit so you can see everything. Okay, so example 1 says, during a flu season, the probability of coming into contact with someone carrying the flu virus is about 0.04. So it says, what is the variable x and how is it distributed? So, right, the variable x, so x is equal to, right, the variable, it says the probability of coming into contact with someone carrying the flu virus. So the probability of coming into contact with someone carrying the flu virus. All right, so then it says, how is it distributed? So let's take a look at, it is going to be a binomial distribution, but let's talk about sort of why. So binomial distribution, right? So I'm going to scroll up just for a minute. What we want to do is we want to go through these 4 steps we had listed above. So, right, fixed number of trials, which means the experiment is repeated in a specific number of times. So it doesn't tell me the actual number of times, but it actually does do that in E and E. So, how many people. So it maybe doesn't definitely define that, but later on it does. The second thing that N are independent trials, which means that what happens on one trial does not influence the outcome of other trials. So if we think of people, right, with the flu, if some random person down the street gets the flu, it shouldn't affect whether you get the flu. So they should be independent events. Third says there are only two outcomes, which are called a success and a failure, right? So if you think of getting the flu, you either get it or you don't, right? It's a yes or no question. And then the probability of success doesn't change from trial to trial, right? They're independent trials, so everyone, right, whoever's coming in contact with this flu virus, right, is always 0.04. So that's why it would fit a binomial distribution. All right, so it says, what is a success in this case, right? The success would be coming into contact with someone carrying the flu virus. Again, maybe not something that we see as positive, but in context, that's what a success is in our case. So a success is coming into contact with someone carrying the flu virus. Flu virus. All right. So now it asks to say, what is the probability of success? So if we're saying that the success, right, is that the probability of coming into contact with someone carrying the flu virus, right, and I guess I should note for A, it should be, right, it's the number of people. All right, so however many there are. But what is the probability of success? Well, that is what they told us, right, that value, 0.04, right, that would be success. For my failure, as long as I know what the success is, you can figure out the failure pretty easily. So 1 minus 0.04. So 1 minus 0.04, or, right, you maybe have found that the failure is 0.96. Okay. So now it says, well, now suppose you have a classroom of 28 people. Find the mean number of successes and interpret the meaning of your answer. So my mean for a binomial distribution is n times p. So n, right, they told us is going to be 28, and the probability of success is 0.04. So 28 times 0.04, right, we get roughly 1.12. So what does that mean, right? So it would mean that on, let's see, let me start off it a little bit differently. So in a room of about 28 people, on average, 1.12 would come in contact with someone carrying the flu virus. Okay, so flu. So it's just telling us, right, that on average, we'd expect, 1.12 would come into contact, right, people. So then it wants us to find the standard deviation. So my standard deviation is the square root of n times p times q. So in our case, right, n was 28, p was 0.04, and q was 0.96, right? And that was all found from previous letters. So if I take the square root of 28 times 0.04 times 0.96, we roughly get 1.0369, something along those lines. So finding the mean, finding the standard deviation is actually probably the pretty easiest for all of the distributions that we're going to do. So as long as you know the number, right, the number of trials you're doing, and then the probability of success, you can find your mean and your standard deviation quite easily.